Hello friends, welcome back to my channel. Today I would like to share with you the concepts of bonding. All chemical reactions happen because atoms are trying to get a full outer shell of electrons. The total number of atoms is the same before and after the reaction. When an atom reacts with another atom to form a chemical bond, it will either lose electrons to form a stable positive ion, gain electrons to form a stable negative ion, or share electrons to form a stable molecule. What is the difference between an atom and an ion? An atom has the same number of protons and electrons. An atom has no overall electric charge. If an atom loses or gains electrons, it's no longer called an atom, it's called an ion. An ion has a full outer shell of electrons. An ion is either positive or negative because it has an electric charge. Formation of negative ions. Atoms gain electrons in their outer shell when they form negative ions called anions. These ions are negative because they contain more electrons than protons. As you can see here, electronic configuration of oxygen atom is 2 and 6, and oxide ion O2- is 2 and 8. An oxygen atom gains 2 electrons to form an oxide ion. Formation of positive ions. Atoms lose electrons from their outer shell when they form positive ions called cations. These ions are positive because they contain more protons than electrons. Sodium atom becoming sodium ion. A sodium atom loses 1 electron to form a sodium ion, which is a cation. What do you mean by an ionic lattice? An ionic compound is a giant structure of ions. The ions have a regular repeating arrangement called an ionic lattice. The lattice is formed because the ions attract each other and form a regular pattern with oppositely charged ions next to each other. The left side figure represents a two-dimensional space-filling model for the ionic lattice in sodium chloride, and the right side figure represents a three-dimensional space-filling model for the ionic lattice in sodium chloride. A three-dimensional ball and stick model for the ionic lattice in sodium chloride is given here. Remember that the lattice arrangement is giant. For example, a single grain of salt may contain 1.2 times 10 to the power 18 ions. The lattice arrangement continues in 3 dimensions. This is why solid ionic compounds form crystals with regular shapes. What do you mean by an ionic bonding? Ionic bonding only occurs between a metal and a nonmetal. Ionic bonds are formed when metallic atoms give away valence electrons to nonmetallic atoms. By giving electrons, metal becomes positively charged, and on the other hand, by gaining electron, nonmetal becomes negatively charged. These oppositely charged attracts each other through strong electrostatic force of attraction, forming the ionic bond. Ionic bonding in sodium chloride. Sodium 281 has 1 electron more than a stable noble gas structure 2,8. If it gives away that electron, it would become more stable. Chlorine 287 has 1 electron short of a stable noble gas structure 288. If it could gain an electron from somewhere, it too would become more stable. The answer is obvious. If a sodium atom gives an electron to a chlorine atom, both become more stable. Ionic bonding in sodium chloride dot and cross diagram. Ionic bonding in magnesium chloride. This is another example of ionic bonding, where magnesium gives 2 electrons to chlorine. Thereby, magnesium gains 2 positive charge, and chlorine, there are 2 chlorine atoms. Each chlorine gains 1 negative charge. Another example for ionic bonding is sodium oxide. Here you can see each sodium atom is giving 1 electron to oxygen atom. The sodium gains a positive charge, and oxygen, since it receives 2 electrons from both the sodium, it gains 2 negative charges. Ionic bonding in magnesium oxide is also shown here. Magnesium gains 2 positive charge, oxygen 2 negative charge. Properties of ionic compounds. High melting points and boiling points. Ionic compounds are held together by many strong electrostatic forces between the oppositely charged ions. These forces are usually referred to as ionic bonds. As the ionic lattice contains such a large number of ions, a lot of energy is needed to overcome these ionic bonds, so ionic compounds have high melting and boiling points. Conduction of electricity. Ionic compounds conduct electricity when molten to form a liquid or dissolved in water to form an aqueous solution. This is because both processes make their ions free to move from place to place. Ionic compounds cannot conduct electricity when solid, as their ions are held in fixed positions and cannot move. Simple molecules and covalent bonds. A covalent bond is formed when 2 atoms share electrons to obtain a noble gas configuration. Covalent bonding occurs between 2 nonmetal atoms. What are the features of covalent bonding? The bond is formed by the sharing of a pair of electrons between 2 atoms. Each atom contributes 1 electron to each bond. Molecules are formed from atoms linked together by covalent bonds. Example, hydrogen molecule. 2 hydrogen atoms gives you a hydrogen molecule where a shared pair of electrons, which makes a covalent bond possible. The displayed formula of H and H hydrogen molecule is shown here. Next example is chlorine molecule. Chlorine, 2 chlorine atoms gives a chlorine molecule. Here you can see 1 pair of shared electrons, which gives to 1 covalent bond between chlorine atoms. Another example is water molecule. Oxygen shares its electrons with 2 hydrogen atoms, forming 2 bonds, one each between O and H. The displayed formula is shown over here. Next example is methane molecule. Carbon shares its 4 electrons with 4 hydrogen atoms, forming 4 covalent bonds. Another example is ammonia molecule. NH3. Nitrogen is sharing its 3 electrons with 3 hydrogen atoms, and it has 1 lone pair which does not take part in bonding. So there will be 1 lone pair and 3 bonded pairs here in ammonia. Next example is hydrogen chloride molecule. 1 hydrogen and 1 chlorine shares its electrons, forming a single covalent bond between hydrogen and chlorine atom. Another example is carbon dioxide molecule. Each carbon shares its 2 electrons with each oxygen atom, thus forming 2 covalent bonds between carbon and oxygen. Another example is ethene molecule. There are 2 carbon atoms. In between 2 carbon atoms, you can see a double bond because it has shared 4 electrons, 2 pairs of electrons. And in between carbon and hydrogen, you see a single bond because there involves a sharing of just 1 pair of electron. Next example is ethanol molecule. In ethanol, there are 2 carbon atoms, 1 oxygen atoms, and hydrogen atoms. So you will see one sharing between both the carbon atoms, which gives you single covalent bond. You can see single covalent bond between every atoms here, as there involves only one sharing, one pair of electrons getting shared. The next molecule is oxygen molecule. O, double bond O. Double bond arises because of 2 sharing pairs. Nitrogen molecule is an example which has got triple bond between 2 atoms. Triple bond arises because nitrogen shares its 3 electrons with the other nitrogen, thus forming 3 pairs, 3 sharing pairs, which gives rise to 3 covalent bonds between 2 nitrogen atoms. What do you mean by simple molecular substances? A covalent bond is a shared pair of electrons. Covalent bonding results in the formation of molecules. Properties of simple molecular substances: low melting points and boiling points. There are intermolecular forces between simple molecules. These intermolecular forces are much weaker than the strong covalent bonds in molecules. Very little energy is needed to overcome the intermolecular forces, so simple molecular substances usually have low melting and low boiling points. The next property is conduction of electricity. A substance can conduct electricity if it contains charged particles, and these particles are free to move from place to place. Simple molecules have no overall charge or charged particles that can separate, so simple molecular substances cannot conduct electricity even when it's liquid or dissolved in water. What are giant covalent structures? Giant covalent structures contain very many atoms, each joined to adjacent atoms by covalent bonds. The atoms are usually arranged into giant regular lattices, extremely strong structures because of many bonds involved. The giant covalent structure of diamond. Carbon has an electronic arrangement of 2, 4. In diamond, each carbon atom bonds with 4 other carbon atoms, forming a tetrahedral structure. As a result, diamond is very hard and has a high melting point. This explains why it is used in cutting tools. It does not conduct electricity, as there are no delocalized electrons in the structure. The covalent structure of graphite. Graphite is a form of carbon in which the carbon atoms form covalent bonds with 3 other carbon atoms. This means that each carbon atom has a spare electron, as carbon has 4 outer electrons, which is delocalized between layers of carbon atoms. These layers can slide over each other, so graphite is much softer than diamond. It is used in pencils and as a lubricant. Graphite conducts electricity due to the spare electrons being delocalized between the layers. This conductivity makes graphite useful as electrodes for electrolysis. However, graphite still has a very high melting and boiling point because the strong covalent bonds that hold the carbon atoms together in the layers requires a lot of heat energy to break. The next comes the giant covalent structure of silicon dioxide. Silicon dioxide is also known as silicon 4 oxide. Crystalline silicon has the same structure as diamond. Notice that each silicon atom is bridged to its neighbors by an oxygen atom. Properties of silicon dioxide. It has high melting point around 1700 degrees Celsius. Very strong silicon-oxygen covalent bonds have to be broken throughout the structure before melting occurs. It's hard due to the need to break the very strong covalent bonds. Doesn't conduct electricity. There aren't any delocalized electrons. All the electrons are held tightly between the atoms and aren't free to move. The next is metallic bonding. Metal atoms are held together strongly by metallic bonding. Within the metal lattice, the atoms lose their valence electrons and become positively charged. The valence electrons no longer belong to any metal atom and are said to be delocalized. They move freely between the positive metal ions like a sea of electrons. The metallic bond is the force of attraction between the free moving or delocalized electrons and positive metal ions. The link between metallic bonding and the properties of metals. Most metals are malleable. They can be bent and shaped without breaking. This is because they consist of layers of ions that can slide over one another when the metal is bent, hammered, or pressed. Due to the ions sliding over each other, most metals are ductile. They can be drawn or pulled into wires, making them suitable for electric cables. Metallic bonds are strong, so metals can maintain a regular structure and usually have high melting and boiling points. Metals are good conductors of electricity and heat. This is because the delocalized electrons can move throughout the metal. Thank you so much for watching this video.